Today's our topic is electric charges and fields. Electric charges and fields. This is the first chapter in the electricity part. First chapter in the electricity part. In the electricity part we have 4 parts. First one is static electricity. Static electricity. And second part is the current electricity. And third one is electromagnetism. And fourth one is the electromagnetic induction. These are the 4 parts we have in the electricity part. First one is static electricity, second one is current electricity, and third one is electromagnetism, and the last one is the electromagnetic induction. Okay, in the electricity part we are going to discuss all these chapters. Firstly, the static electricity. Static electricity. In the static electricity part we have 2 chapters. That is the first one, electric charges and fields. That is we are going to discuss today, electric charges and fields. And the second one is the potential and capacitance. And second one is potential and capacitance. These are the 2 chapters. This is the 4th chapter in our syllabus and this is the 5th chapter in our syllabus. So these 2 chapters come under static electricity. These 2 chapters come under static electricity. Okay. So first we are going to discuss electric charges and fields. So this is a chapter which comes under static electricity, or this can also be called as electrostatics. Electrostatics, which means the effects of, in this part we study the effects of electric charge when it is at rest. When it is at rest. Okay. So in this part we discuss the effects and properties of an electric charge when it is at rest. That is why this part is called as static electricity. Static means stationary, or which is also means rest. So when the electric charge is at rest, we study the effects and properties of that charge. So that is static electricity. Okay. And what is a charge? An electric charge. What is an electric charge? Electric charge is a basic property. Electric charge is the basic property Electric charge is the basic property which shows electric and magnetic effects. Which shows electric and magnetic effects. So this is the basic property of matter which shows electric and magnetic properties or magnetic effects. So basically that is a charge. We know that charge is possessed by the charged particles like protons and electrons. These are the fundamental particles of an atom, protons and electrons. Protons are the positively charged particles and electrons are the negatively charged particles. Protons are the positively charged particles and electrons are the negatively charged particles. Okay, so because of these particles, a substance can get charge. Because of these particles, charged particles, a substance can get charge. Okay, so how a body can be made a charged body? How a body can be converted into a charged body? So basically a body is neutral. Body is neutral, that means chargeless, because why the body is neutral? Because atoms are neutral. Because atoms are neutral. Why the atoms are neutral? We know that atomic number. Atomic number is nothing but number of protons or number of electrons. Okay, we know that atomic number is nothing but the number of protons or number of electrons present in an atom. Okay, so we know that the number of protons and number of electrons are equal and each proton and each electron carries 1 unit of charge. 1 unit of charge. Therefore, the net charge on an atom, is always equal to 0. Okay, because the amount of positive charge present on the atom is equal to the amount of negative charge present on that atom. Okay, therefore the amount of positive charge is equal to amount of negative charge. Therefore the net charge on an atom is always 0. Therefore we can say atoms are neutral. Atoms are neutral. So how a body can be made charged body? How a body can be made charged body? When its atoms are neutral. Okay, so to make a body charged body, the process is called the process of giving charge. The process of giving charge to a body is called electrification. Is called electrification. The process of giving charge to a body is called electrification. That means conversion of a neutral body to a charged body. Conversion of a neutral body to a charged body is called as electrification. Okay, so the electrification process can be done in three different ways. The electrification process can be done in three different ways. One is, that means a neutral body can be converted into a charged body by means of friction. By means of friction. And secondly, by means of conduction. By means of conduction. And third method is by means of induction. These are the three processes or three methods by which we can convert a neutral body into a charged body. Okay. So electrification is nothing but the process of converting a neutral body into a charged body. That is called electrification, and that process can be done in three different ways. One is by friction, second one is by conduction, and third one is by induction. Okay, I hope you are all noting down. Okay. Next one. Now firstly we are going to discuss the method of friction. How a neutral body can be converted into a charged body by means of friction. Okay. So in this process of friction, we consider two neutral bodies. In the process of friction, we consider two neutral bodies. Let them be, first one A and second one is B. And initially these two bodies are neutral bodies. Initially these are neutral bodies. Now, if the two bodies are rubbed together, then one body loses electrons, some electrons, and the other body gains those electrons. Okay. So when we rub these two bodies together, these are the initially neutral bodies, and when we rub these two bodies together, one body, out of these two bodies, one body loses some electrons, and those electrons were gained by the second body. Okay. Now when the first body loses some electrons, the body which loses electrons, the body which lost electrons becomes positively charged. Let us consider here A lost some of its electrons, then A becomes positively charged. Okay? And when it loses some of its electrons, it becomes less weight. Its weight also decreases. Its weight also decreases because of the loss of electrons. Because of the loss of electrons, the first body, let it be A, it gains positive charge and it loses some of its weight. Okay? And the second body, let it be B, that acquires those electrons and becomes negatively charged. So B becomes negatively charged, and as it gained those electrons, its weight increases. Its weight increases. Okay? So by this process, we can make neutral bodies into charged bodies. Okay? So this is the first method of making a neutral body into charged body, that is the process of electrification. Okay, please note down. By the process of friction, when the two neutral bodies are rubbed together, when two neutral bodies are rubbed together, then one body loses some electrons, and the other body gains those electrons. And the body which loses or which lost electrons becomes positively charged, and its weight also decreases because it is losing electrons. Okay, and the second body, we are considering that second body as B. That body will gain negative charge, so it becomes B minus, and its weight increases. So this is the process of friction. Okay. Okay, next one. By the process of conduction, that is the second process. By the process of conduction. Okay, in this process again we consider two bodies. In this process also we consider two bodies, but one is already charged and the second one is neutral. Okay, so when a neutral body is connected to a charged body, then the neutral body gains half of the charge, a same type of charge, half of the same type of charge which is on the charged body. Okay, so in this process we consider two bodies, one is charged body and the second one is neutral body. So here we have to convert that neutral body into a charged body. Okay, so to convert that charged body, just we connect that neutral body to the charged body. We have to connect that neutral body to the charged body. Then when we connect that neutral body to the charged body, it will acquire half of the amount of charge, and same type of charge which is on the charged body. Okay, so let us consider again two bodies. One is A and the second one is B. Let A is already positively charged. And B is neutral. But when we connect these two bodies by means of a conductor, if we connect these two bodies, then B will acquire the same type of charge which is on the first body. So here the first body is of positive charge, so this charge is transferred to the second body, so B also will get positive charge. Okay, how much amount of charge will be transferred to the B is half of the amount of charge. Okay, the charge which is present on the first body is shared by these two bodies. The total charge is shared by the two bodies equally. So in this process, the total charge is shared by the two bodies equally. Okay, so this is the process of conduction. Okay, ma noted. Okay, I'm erasing. Next one is the third process, that is by induction. by induction. This is the last process, a third process, by which we can convert a neutral body into a charged body. So in this process also we consider two bodies. Again, one is charged body and the second one is neutral body. Okay. So in this process we consider a neutral body and a charged body, and when we place the neutral body very near to the charged body, then the neutral body gains an equal and opposite charge to that on the neutral charged body. Okay. So here we have to place the neutral body very near to the charged body only. Okay, we should not connect it to the charged body. If we connect that neutral body to the charged body, what will happen? It will convert into the conduction process. Okay. So then the second body will acquire the same type of charge. But in this case of induction, we have to place the neutral body only very near to the first body, that is the charged body. Then when we place that one very near to the charged body, what will happen is that neutral body gains an equal and opposite charge. Okay. So let A is the positively charged body and B is neutral body. A is positively charged body and B is neutral body. Now we are going to place this neutral body very near to the first body without contacting the first body. Okay. The second body should not get into contact with the first body. Just it has to place very near to the first body. Then what will happen? This second body will gain opposite charge. That means if A is a positively charged, then B will get an equal amount of negative charge. Okay. So this process is called induction process. So here we can call the charged body induces an equal and opposite charge on the second body. Okay, so in this process also the neutral body converted into a charged body. Okay, so by these three processes, that is friction, conduction and induction. we can electrify a body. Okay. So in all these three types of process, the neutral body is converted into a charged body only by the removal or addition of electrons only. Okay, we cannot convert a body into a charged body by the removal of protons. We can done it only by the removal or addition of electrons only. So in the first process, that is in friction, what will happen is, when A body and B body are initially neutral, when they are rubbed together, some of the electrons are lost by the first body, and those electrons are gained by the second body. So in that process also, so electrons transfer is taking place. In the second process also, in the conduction process, electron transfer also only taking place. In all the three processes, only transfer of electrons only takes place. So we can make a neutral body into charged body only by the removal or addition of electrons. Okay, students, if it is get disconnected, please rejoin. If the class get disconnected, please rejoin. Your class will be from 10:10 to 11:10. Okay. And next one, in the next part or the next topic, we discuss the properties of a charge. Properties of a charge. So we already discussed that charge is electric charge. It is the basic property. It is the basic property of matter. It is the basic property of matter which shows electric and magnetic effects. Which shows electric and magnetic effects. Okay. So this is called an electric charge. Electric charge, basically it is denoted by, we denote electric charge small q or capital Q. We use the denotation of small q or capital Q for a charge, and it is measured in coulombs. It is measured in coulombs. Symbol is C. Okay. Generally, coulomb is a large unit. Coulomb is a large unit, so that we measure the charges in microcoulombs. So we measure charge in microcoulombs. microcoulombs, that is 10 power minus 6 coulombs, nanocoulombs, that is 10 power minus 9 coulombs. Okay, generally we measure the charge on a body in microcoulombs, that is 10 power minus 6 coulombs, and nanocoulombs, that is 10 power minus 9 coulombs. Please note down. Since coulomb is a large unit, why it is large unit, that we discuss later. Why it is called a large unit. So that is why we measure the charge in micros and nanos, and sometimes picos also. So this is a charge which shows electric and magnetic effects. Electric and magnetic effects. Okay. We have already seen how a body can be converted into charged body. So charge is a basic property. That means basic property of matter. So matter comprises of molecules, and molecules are made up of atoms, and atoms are made up of fundamental particles like protons, electrons and neutrons. So every matter or substance consists of charged particles, protons and electrons. So that is why charge is a basic property. Charge is the basic property. We have to convert a neutral body into charged body by means of the three methods we have discussed earlier. Okay. So now we discuss the different properties of an electric charge. Different properties of an electric charge. Properties of a charge. Please mute yourself, Amma. Properties of a charge. First one is charge is additive. Charge is additive, which means we can add the total charge. For example, if a body contains plus 10 coulombs of charge, and a body B contains minus 5 coulombs of charge, and a body C contains plus 5 coulombs of charge. Okay, so what is the total charge means? We can add these three amounts of charges on the three bodies on the system. If we are asked what is the total amount of the charge on the system of these three bodies, we can simply add these three amounts of charges, that is 10 coulombs, that is plus 10 coulombs. Let it be Q1 and this is Q2 and this is Q3. Then therefore the net charge on the system of three bodies, net charge on the system of three bodies is equals to Q1 plus Q2 plus Q3. That implies Q1 is 10 coulombs and Q2 is minus 5 coulombs and Q3 is plus 5 coulombs. Therefore we get 10 coulombs. That is the total charge present on the system. Okay. So whatever may be the charge present on the body, we simply add them up. Then we get the total charge on the system. So here the system of three bodies A, B and C. Let the charge on A is Q1, charge on B Q2, charge on 3 is Q3. Then the net charge will be Q1 plus Q2 plus Q3. In this example, we have Q1 is 10 coulombs, Q2 is minus 5 coulombs and Q3 is plus 5 coulombs. Therefore, the net charge on the system will be equal to 10 coulombs. Okay. So this means charge is additive or addition of charges. Addition of charges. Okay. The total charge on any system is equal to the sum of the, if we want to define this property, we can define like this: the total charge on a system is equal to the sum of the individual charges. Sum of the individual charges on the bodies. So if capital Q is the charge on the system, we can write this as Q1 plus Q2 plus Q3 plus so on. This is the net charge or total charge on the system. So this is the property of the charge, which is called charge is additive. Charge is additive. Okay, this is the first one. And the next one, second one is charge is invariant. Charge is invariant. That means not variable. Charge is invariant means not variable, or the amount of charge on a body does not changes. This means the amount of charge on a body does not changes if the body is at rest or it is in motion. Okay, so that means the amount of charge does not changes with the speed of the body. That is invariable. The amount of charge remains same whether the body is at rest or it is in motion. It does not changes. That is called invariance of the charge. This property is called invariance. Invariance of the charge. Invariance of the charge. Okay, and next one, the third one is charge is conservative. Charge is conservative or charge is conserved. Charge is conserved. That means the total charge on any system remains constant. The charge on any system remains constant. Okay, this is called conservative property of the charge. Conservative property of the charge. In the first method of electrification, that is by friction, we can observe the conservative nature of the charge. Okay, so there we considered two neutral bodies, and when they rub together, one body lost some of electrons and those lost electrons were gained by the second body. Okay, then the first body gains positive charge and the second body gains equal amount of negative charge. Okay, so what is the net charge before the friction? Before the friction is the two bodies are neutral. That means the net charge on the system of two bodies. The net charge on the system of two bodies is equal to 0 before the friction. What is about after the friction? The amount of charge, positive charge, is equal to amount of the negative charge. Okay, if A get 1 coulomb of positive charge and B gets minus 1 coulomb of negative charge, okay, then the net charge on the system is always remains constant, that is 0. Okay, but the individual charges have been changed. Initially it is of neutral and it is also of neutral, but now after the friction it is of positively plus 1 charge and it is of negatively charged having minus 1 coulombs of charge. But when we consider the total charge of the system before and after the process of friction, before the process the total charge on the system is 0, and after the process of friction the total charge on the system is again 0. That means the total charge on any system remains constant during any process. Okay, so before the process is equals to after the process, the total charge remains same. This property of the charge is called as conservative property of the charge. Okay, so this is the third property. The total charge on any system remains constant. And the fourth property, which is very important to us, charge is quantized. Charge is quantized, or this can also be called as quantization of charge. Quantization of charge. What is quantization means? What is quantization? Quantization means the charge on any body, can be expressed as the integral multiples of charge on one electron. The integral multiple of charge on one electron. So this property is called as the quantization of charge. That means the charge on any body can be expressed as the integral multiple of charge on one electron. So these are the four main properties. We will discuss this quantization of charge in the next class elaborately, because on this property we have some number of problems. So these are the main properties, and other properties are also there, which we'll discuss in the next class. So first one is the charge is additive, second one is charge is invariant, third one is charge is conserved, and the last one and important one is the charge is quantized. The quantization of charge can be written as in the formula Q is equal to plus or minus Ne. This property can be expressed as mathematical form as Q equals to plus or minus Ne. Here Q is the charge on the body, N is the integer, and E is the charge on an electron. The charge on an electron is denoted by small e. So we can write as the definition defines, the charge on any body, that is Q, can be expressed as the integral multiple, that is N, of charge on one electron, that is E. So we can write Q is equals to plus or minus Ne.